let's continue to the, I hope it's the last video for this project 08. Let me save a new model file. In the GitHub, you can see you can already watch the file. We already push all the snapshot model file there. So what we are still missing are the leaves of the tree. We can use the branch depths to draw leaves instead of a branch in the last recursive. So that means the leaves is we treat that just the last depths of the branch, but we will draw that not like a branch, we draw that like a leaf shape. So let's continue. So first we don't add any new parameter. So we're starting to have, you can put that larger, but when you click here, you put your model in the middle. So that is our tree now. And we're starting from this one, so run to value. And we have this function, z, from to idx. That's no change. And we are adding here, so if branch depths, let me see, R3, smooth, should we branch, children more than this, else branch minus branch 大于 more than 0 should we branch. So these are still having that. But before that, we will add, we check its branch depth is more than 0. And then let's see, so we have this one, the children linear function. Let's examine is how we add those additional code. Color. So here we, if that is less than 1 and the children, so we should have our children more than 1. So that after this function, let's add that from here. We don't need this SF part. Branch depths less than 1 and $children more than 1. So we will do something. So that's the if. And I hope is we put everything else to the else. So let's do this if first. So leaf, we gave leaf color green. So that's understood. Rotate. Leaf also need to have different angle. So first is the floor. It's one mathematical calculation to do this floor with run seed. Get divided by 2 in the integer. If that fulfilled is rotate 45 degrees, otherwise is rotate minus 45. So that's the x. The degree is 2x XL, and no change for y and z. XLs we don't need rotate, and we make height is leaf is very thin, so just give our 0.1. We can change that later to test, and children 1. So that is our branch, and now is here syntax. So recursive, because we need to use else to close the rest of the things. So those are if should branch, and we are putting this close here, this close here, and we count this one, this finish, this should be branch, this is here, and go to the else. Here is the else, and we go to the depths, this one, and we have those calculation, and translate this one, this same, and R3 scale. Here we should add this children one. That's more than one, and children one is here. Then smooth out connection of the branch path, skip. Then we go to the min parts. If those are same, and then we also add this checking children -1, then children 1, and smooth this else if those are min, and we give a scale here, so that's the same. If $children more than 1, then get children 1, and here, and what we have another one is the branch depths. If not more than 2, then children more than 1 is a 2 condition. Then we will have another color, green. This define the leaf. So same as above. I hope I have all the typo, no error. 45, O minus 45, 0, 0, and then linear weight 0.1 and the children 1. Now let's count this. Here is 1, and we should close that more than 1. The else. So this is else, and we should have 4 4 here. And this is go to the upper else. Let's go to here. And this one, let's go to here. Children 1. So we should have a semicolon. I hope that's. Let's see the save design parse 146. Children, yeah, I think it's the typo. Great. So now there's, but where is the leaf? I think we need to give the perimeter. So square is the leaf. And we have a BD initial not 1. Let's save first. So we have a leaf started. Let me save this first. Okay, that's the initial leaf. And now we can start to change this BD initial. Let's change one by one. We have a 2, 3. No effect. 4, and we should have this one. So 3. Okay, we have not so many leaves. We have 4. Hope that gave more leaf. Not so many. D plus, so we can have a long leaf. C. Hope we can have that leaf is looks good. Any other parameter we can change? As we use the other geometry passed to our module from outside. So this is circle children 1, 0, children 1. So we use this to do that. Accordingly, we need to update all recursive uses of R tree within our module and also pass the geometry children 1 along. Yeah, so those are the things. With this, we have done. If you want to automatically create some random tree, you can now make the parameterized. So let me save this to another one. But this kind of model, if you want to print that in the printer, it's not easy to clean because you have to have a lot of supporter from bottom. And when you cut those supporter after print, it's quite fragile, I believe, for those leaves. So such kind of part is art, but it's not so easy to be printed. So we can add parameterized test instance as follows. So srnd, we have this srnd now. Runs from 0 to 1000, just generate 1, and I need this in the first, and we can echo srnd. So let's just echo that. So it's here. So we got our 811, and let me save this again. It's always get this one. So let me use that is the seed. So if I go to seed is here. So I go to our random, like 811. And then what we are using is we use this seed by srnd. So you can see now, every time is we'll get a different number, then your tree is change their style. So now this one, which tree you like, is depending on every time is changing. Oh, this one is good. Yeah, I like this. This looks like a natural tree. And we can have our branch angle. So here we can change this, and this make that bigger. But I don't have so many leaves. So square, let me see, here is R decrease is 07, 2020, this one, now 4450. Let me change this depth to 5. Let's see. Okay, I think that looks nice. A tree with a branch of 40 degree. This is with the 60 degree. So you can change those degree to have some more ideas. But after all, until now, we have our tree, and every time you get you just save that, you will get a new tree to be generated. So that's all for this project 8. Thank you for your watching. So next project, we have just 2 projects ahead. So we will have our parabolic reflector. So that is interesting. Is we may have a more physical calculation and then to have some analysis on the motion. So thank you for watching till now. See you in the next project. Bye for now.